Okay, so first one is for sine. So you can go backwards and forwards. If you see, let's say you have an angle inside of a sine, you can split it. Something that is, on the circle, and then break them into these sums and differences. Okay. Like for example, let's say you had, I don't know, sine of one, well, kind of like 75, right? You could separate that into 45 plus 30. And all those would then be on the circle. Okay. You can choose how to split them, how to subtract them, whatever. We'll do an example in just a moment. But as you can see, they're kind of easy to remember. See how these two are the same, they're just based on this plus, you put a plus there, right? Based on this minus, you put a minus here. Otherwise, it's the same thing. Cosine is the opposite. You got a plus, put a minus. You got a plus, you got a minus, put a plus. You don't have to memorize them, but I would add this to the formulas I've been giving you. Just create a big page. For this exam, you might actually have a whole page of just these identities. So feel free to keep adding to it. All right. And if you somehow forget, I'll put it on the board for you during the exam. It's not a big deal. Just let me know. Okay. Okay. So we are going to need a unit circles, so help me out here. Find the exact value. So no calculator stuff, just the values from the circle. So cosine of, I'll go ahead and split it for you. 5 pi over 4 minus pi over 6. So when you see this, you should be thinking, okay, well, I have an alpha and a beta. It looks like the second formula, right? So just plug in the alphas and betas in the correct spots and find them on your circle. That's it. That's all you're doing. So you would get cosine of 5 pi over 4 cosine of pi over 6. If it's minus, it's a plus. Sine of 5 pi over 4 times sine of pi over 6. So what is cosine of pi 5 pi fourths? On your circle, what is cosine of 5 pi fourths? I don't know what it is. I don't remember. So, 5 fourths would be here. Like it's a 225 somewhere on there. Is that right? So what is the, yeah, what's the cosine there?
It's negative square.
Negative square root 3? Okay, thank you. Cosine 5 pi over 6, that's the first quadrant, right? Oh, 2, right? Okay, cosine
Cosine is 3. Negative square root 3 over 2.
for this one,
No, square root, yeah,
that's a 3?
it's 5, 5, 5, right?
Yeah, 5/5. Yeah, let me double check.
Oh, no, yes. I'm thinking about.
Oh, okay. Okay, we're good. What about this one? Oops. Cosine pi6, that should be right at the beginning. Yeah, that's the 3, right? Okay. This one should be the same as this one. And they're both negative, right? Like pi over 5, pi over 4.
Yeah.
This one should be a half. Okay. All right. At that point, you have all the exact pieces, just multiply them together, add them together. That's all you can really do. So negative root 2 times root 3 is a root 6. Right? You can multiply radicals. When you do, you multiply the inside only if they're the same type. Like if they're both square roots, you can. The bottom, just 2 times 2. And then these two, negative root 2 times 1, well, that's negative. 2 times 2 is 4. So the final answer will simply be negative root 6 minus root 2 over 4. Yeah.
How come you change that's for like?
Oh, it's negative. Negative times positive here. It's going to be minus. Yeah, this is positive times negative, so negative, positive, negative times positive, negative. Then I just put these together into one fraction. That's all you can do. They don't simplify. But this is the exact answer. Okay. Okay. But you see how they use the formula. Is this part okay, or is it clear? We'll do another one where it's a little harder. Well, you need to choose how to split it up. So this one was split for you. So you'll split it up yourself. All right. I'm gonna turn the page up. You guys still on this one? All right, number 2. So here you have to decide. On the exact values or value for cosine of 75 degrees. So choose your alpha and beta, split the 75 degrees into something that is on the circle, to 2 angles that exist on the circle. So what would you choose? So if you add 2 angles together, they add up to 75 that are also on your circle. Is that obvious? You can also do the differences if you wanted to. As long as it equals 75, it doesn't matter. So you can choose 30 plus 45. Do you agree that 30 plus 45 is 75 degrees? So now that you split it this way, apply a formula and all the alphas and betas would be using these. So you'll get your exact solution from the circle, your unit circle. So right here we get formula says cosine 30 cosine 45 minus sine 30 sine 45. I'll just look them up and that's it. Cosine 30 3/2, cosine 45 minus sine 30 That's it, right? Now just multiply it out and you're done, just like before. So √3 times √2, 2 times 2, 1 times √2, 2 times 2. And we're done. So the first couple of homework problems will be something simple like this, and then it gets back to proofs. Okay. Okay. Yes, cool. Number 2. Mhm.
So for instance, we take the negative, right? Say, next to formulas, but it doesn't plug in. No. How do you distinguish when to predict?
Well, it's based on whatever's in the middle. If it's plus for cosine, you gotta use minus here. If it's minus, then you should have a plus. Example 3 is a little harder. Yes, you're cool with number 2? Good. So this one is a little weird. Find the exact value. We're going to use these formulas right here. I should have wrote them earlier, but that's okay. We know that sine theta, if you solve for it in the Pythagorean identities, is equal to plus or minus the square root of 1 minus cosine squared, which means that cosine theta is equal to plus or minus the square root 1 minus sine squared. So we're going to need these in a moment. So they wanted to find the exact value of sine of cosine inverse of 1/2 plus sine of sine inverse of, I think it's 3/5. Yeah. So remember how before we had that, I think in the exam we had like sine of tangent inverse or something, and you would build a triangle. So same type of stuff, except you have a sum of inverse functions. So it's the same thing you've done before, it is more complicated. Yeah, I guess extra steps. So what we did before, right, we said let the inside equal to some angle, and then we would use the definitions, right? So you use a definition for each one. So this is how you start, right? Step 1. Let alpha equal cosine inverse of 1/2. And beta equal sine inverse of 3/5. At this point, apply your definition, okay? The definition of the inverse trig functions. All right, so you're gonna get there. This means that let me show the step. Alpha equal to cosine inverse of 1/2 implies that you can have a cosine alpha equal to 1/2. Similarly, beta equal to sine inverse of 3/5 means that sine of beta exists equal to 3/5. Just like before, it should be familiar. Do you remember doing this? Same type of deal. The only difference now is you have two separate triangles instead of just one. But they do have to tell you the location of alpha and beta. Should have put that sooner. Note that alpha is between 0 and pi. And beta, actually, I'm sorry, this is from the domain and range of inverse functions. Remember, we told you that the inverse part is within 0 to pi. And the sine for, or the one for cosine. One for sine is negative pi over 2 to pi over 2. Okay. So essentially what you need to do is solve for sine alpha. Well, we found sine beta, right? So we're gonna need sine alpha. Here we have cosine alpha, we're gonna need cosine beta. Does that make sense? Because once you have it, right, where are we trying to get to? When you apply the formula on this, you're gonna have that formula. Right? If you remember, if you imagine this as alpha plus beta, using the formula, you would get sine alpha cosine beta plus cosine alpha sine beta, right? Once you apply the formula on these two pieces. So you'd have four parts. But you're missing, you only have 2 of the 4. So I need the beta part and the alpha part. Is that clear? Or is that weird? So using this, solve the missing part. So if I have that, I know that sine alpha is equal to plus or minus the square root. Let me write a note here. Step 3. That way we don't get all confused later. Solve for sine alpha and cosine beta. That's the goal. That's the missing pieces we need to apply the formula. Okay. So the formula for sine alpha is equal to plus or minus the square root of 1 minus cosine squared alpha since alpha is between 0 and pi, sine will be positive, right? If it's the top half of the circle, sine is positive there. To plug in your cosine, you get 1 minus 1/2 squared, because that's what alpha, cosine alpha is equal to. So you will get the square root of 1 minus 1/4, which is equal to 1 minus 1/4, what is that? 3/4, right? So that gives you square root 3 over 2. I skipped the fraction step. You guys okay? Do you see it? Or no? You're doing the board real quick if you don't see it. Yes. Because alpha is within 0 to pi, so sine should be positive there. Okay, do I have a third written? No. Oh. Common denominator. The way that would 4 minus 1. Right. The part I didn't show was the LCD and then the square root of, so you square root at the bottom, it's giving you a 2. Square root at the top gives you a 3. Square root 3 doesn't change. Yeah. From here to here? Yeah, so if you square this, 1/2 times 1/2, you're gonna get a quarter, right? Once you get there, introduce 4 over 4, get here. 4 minus 1 is a 3. You want to see one more step? You can separate the radical. Square root 3 stays, square root 4 is a 2. So I skipped some of those steps here because there's not enough space here. Any other questions on how we got sine alpha? Okay, so now we need we said cosine beta, right? So cosine beta is equal to plus or minus the square root of 1 minus sine beta squared. So beta is on the right half. So cosine would be positive as well. Okay. So we get 1 minus 3/5 squared. 1 minus 9/25 over 25 over 25 minus 9 over 25. Doing the fraction step again. So change this to 25 over 25. 3/5 squared is 9/25. Do the math here. You should get the square root of 16 over 25, which will give you a 4/5. Do you see why we're doing this though? I mean, we're doing a lot of stuff, but do you see why we need to? Please note that this is alpha and beta, right? So this is, what they're really asking is, what is sine of alpha plus beta? So you would apply the formula to this. Once you've applied it, you would plug in these guys and these. Is that clear? We'll do it on the next page because I don't have enough room. I'll put it all together on the next page, just a moment. But any questions on this step here? Is it okay? Right. I'll turn the page then. You guys okay then? All right. So all this to say, all that nonsense. The sine, I'm gonna write the question again, of cosine inverse of 1/2 plus sine inverse of 3/5. So we said let alpha equal this first piece. And we said that let beta equal that second part. So then this becomes sine of alpha plus beta. So the formula is sine alpha times cosine beta plus cosine alpha sine beta. Yes. Oh, I knew that was gonna happen. Yeah, I try to stay away from the pretty colors, but I thought it might work.
Or done the brackets.
That might work. Oh, why I think the dark colors. Okay. I'll just rewrite it. It's fine. I'm gonna write the exact same thing. Sine of, big old parentheses. What was it? Okay, so all this is inside, right? Okay. And we said in the beginning that let alpha be the first part. And beta be the second part. So this becomes sine alpha plus beta, which is equal to, you'll find the formula. Sine alpha cosine beta plus cosine alpha sine beta. So we found the missing pieces. You can just plug them in. And we had, and we're given the first two technically once you apply the definition. So we know that sine alpha is equal to, let me write them all down. Square root 3/2. Sine beta was 3/5, right? Cosine alpha was 1/2. Cosine beta was 4/5. That's what we found on the other page, so just to put it all together, because I feel like I didn't explain why we're doing this as well as I should have. We're trying to get this. We were given this, right? This first piece. That's what this is. So apply the formula to that, and you get this. We solve for each of these pieces, so just plug them in, and you're done. Okay, so the answer is going to be sine alpha times cosine beta plus cosine alpha times sine beta. So that'll give us 4 square root 3 over 10 plus 3 over 10, which will become 4 root 3 plus 3 over 10. So this is what they want. This was a long question. Do you have any questions at the beginning or middle? Do you see the big picture? Do you see the goal? Don't be afraid to ask or let me know. I feel like we could have done 2 triangles. It might have been better. I don't know. It would have worked too. But either way, you would have to find all 4 and plug them in. Okay. Give me a moment. I guess it's fine. So let's try the next one using triangles. See if you like that better. I don't know. Maybe you hate it either way. And that's cool too. No, so you guys are okay in this last example. Example 4. Given that sine alpha is equal to 3/5 and that alpha is in the first quadrant, meaning they're not going to straight up tell you, but you should know that by looking at this. Right? Do you see that? That alpha between 0 to pi over 2 means quadrant 1. Is that clear? Which quadrant is this? Yeah, 3. So they're not going to straight up tell you. You need to know when you see these ranges. So 2, 1, and 3. Okay. So this time let's build the triangles. Maybe that's better. I don't know. So what they want you to do is part A, find sine alpha plus beta. Part B, find cosine alpha plus beta. And C, tangent alpha plus beta. So this time we said step 1, build a triangle for alpha and beta. Do it separately. So we got alpha over here. Sine of alpha was equal to 3 over 5. Beta over there. Cosine is equal to -5 over 13. Now this is the magical triangle. So when you try to solve it, you're gonna get a 4 here. When you try to solve for the missing side, you will get a 12. But the question is, for the opposite side, the sine part, is sine negative in quadrant 3? Sine is negative, so you got to put a -12. For cosine, is cosine positive in quadrant 1? So we shouldn't mess with that 4. So when you're solving for these missing sides, let's suppose you didn't see that they're magic triangles. You would have to put the plus or minus and then choose plus because it's quadrant 1. Choose minus because it's quadrant 3. Is that clear? Let's say real quick. Let's pretend we're finding the 3, 4, 5. So we had the 3 and the 5. We had 3 a squared plus b squared equals c squared. We have this guy, and we have this c. We don't know a. So a would equal 25 minus 9. So a would equal 16. So a is the square root plus or minus 16. Plus or minus 4. So you would choose plus. Same thing for the 12. You would choose negative. That makes sense? Okay. So anyway, so this is instead of using the formulas I gave you on the last example. You could have used the formulas if you want to. Doesn't matter. The formulas have that plus or minus built in. So if you like that better, that's fine. But anyway, part A. Sine of alpha plus beta is equal to, what does the formula say? Sine alpha cosine beta plus cosine alpha sine beta, right? Okay. What is sine alpha? So you're gonna have to use a triangle. So plug these 4 things in. Right. 3 over 5 is sine alpha. What is cosine beta? Yeah, it's negative. Oh, yeah, 5. Yeah, you're right. Negative 5/13. Plus, what is cosine alpha? So here's your alpha triangle. What's cosine? The adjacent over the hypotenuse. Don't forget cosine. Okay, sine beta. It's opposite over hypotenuse, but look at the beta triangle. -12 over 13. So do you see how instead of the formula we're using the triangles? If you like that better, feel free to use it. But does it make sense where these numbers came from? Is it okay? So at this point, you just add them together. 3 times -5 is a -15. Actually, these 5s cancel. You know what? I don't want to do that. Because I have to bring it back. Because right now they have the same LCD, right? So let's not cancel, so I can just add them. What is 5 times 13? 65? Yeah. 4 times -12? -48? Is that right? Okay. -15 minus 48. Is that 63? You guys agree? That's it. So that's essentially what we did in the last example. It's just more compact and straight to the point. Okay. Is that clear? Okay, just do part B then. What is cosine alpha plus beta? Formula says it's equal to cosine alpha cosine beta minus sine alpha sine beta. Cosine alpha is, oops, what is cosine alpha? So 4/4. What is cosine beta? -5/13 minus sine alpha. That's 3/5, right? And sine beta? Okay. Any questions where these numbers came from? Is that okay? All right. Multiply this out. 4 times -5. 5 times 13. Negative is going to be plus. 3 times 12. -20 plus 36. Yeah. You see, once you have the triangles built, it's not too bad, right? Okay. Let's do the tangent on the next page. Just a second. You guys cool on those? A, part B. So let me know. Part C was tangent alpha plus beta. The formula is equal to tan alpha plus tan beta over 1 minus tan alpha tan beta. So what is tangent alpha? So look at your alpha. Tangent is opposite over adjacent. So 3/4. So this would be 3/4 plus, oh man, I smeared it. -12 over what? Oh, they're both negative, right? So that'll become positive. Okay. And then again, 1 minus 3/4 times 12/5. So at that point, you're mostly done. Just got to deal with the fractions. This will be 3/4 plus 12/5 over 1 minus, multiply these out, 3 times 12, 4 times 5. These would become positive, right? But this has a built-in negative, so it stays. You guys still with me up to this point? So now just add the fractions, and you're done. The LCD is 4 and 5, so, or 4 times 5, which is 20. Let's do the top, so it changes into a denominator of 20. So 5 over 5 plus this guy times 4 over 4. Change the 1 into 20 over 20 minus 36 over 20. This becomes 15 20s minus 40, plus 48 20s over the same thing. 15 plus 48. Uh, 63, right? 20 minus 36. It's gonna be negative.
How did you get 20 over 20 if 3 times 5 is 15?
Those are the further one.
Yeah, but the bottom part, like after it's 3/4 times 5 over 5, you put 20 over 20.
3/4 times 5 over 5 is 15 20s. That's the top part. The 1 became 20 over 20.
Oh,
Yeah, there's a lot of fractions everywhere, so be careful. So at this point, you'll get 63 20s times 20 over negative 16. So final answer will be negative 63 over 16. Tangent's the more annoying one. I don't know if I'll give you a 10 on the on the exam, but you will see all this stuff on the homework. We got about 15-20 minutes. Let's spend that time on 7.1 or 7.2 homework. You guys have any questions on part C? All right, we'll stop the lecture here.